Welcome to Math Shorts, tantalizing mathematical tidbits that will amaze, entertain, and delight. Math Shorts is brought to you by the Ottawa Zone for Mathematics Education. The Ottawa Zone for Mathematics Education is a chapter of the OAME, the Ontario Association for Mathematics Education. You can find information about both these organizations in the video description. In this first episode of Math Shorts, we're going to take a look at the Pythagorean Theorem. The Pythagorean Theorem is one of the most well-known and most commonly used theorems in mathematics. If you ask many people, they'll even be able to recite off the formula. A squared plus b squared equals c squared. Now, what does that mean and where is it used? Well, some will remember it has something to do with a right-angled triangle. When we have a right-angled triangle, we name the three sides. The side that's across from the right angle is called the hypotenuse, and the other two sides are called the legs. If we look at our formula for the Pythagorean theorem, we've got these letters A, B, and C. The letter C is used for the hypotenuse. The letters A and B are used for the legs. Now, in our formula, we have this a to the exponent of 2, b to the exponent of 2, c to the exponent of 2. We read this as a squared, b squared, and c squared. That tells us that we're actually looking at something else. If I construct a square on the side of our hypotenuse, its area will be c squared. And similarly, if I construct squares on the sides of the legs, they will have areas a squared and b squared. So the Pythagorean theorem is really stating that if you take the squares on all the three sides, the areas of the two smallest squares are going to add up to the area of the larger square. Now, this has many uses, and we'll explore some of these in later editions of Math Shorts. But today we're going to look at something really important, and that's the idea of proof. We have this a squared plus b squared equals c squared, and it's a relationship that holds for every possible right-angled triangle that we have. How do we know that that's true, other than trying a few and seeing that it works? In mathematics, we want better information than that. And so we're going to take a look at a proof that this thing works for every possible value of a, b, and c. Let's look at a truly beautiful proof of the Pythagorean theorem. We'll start by making 4 copies of our original triangle, exactly the same. And now we're going to rearrange those 4 triangles into a square. Now we've created this new square so that each side has length equal to the sum of the 2 legs of the triangle. So we've got the short side and the long side, short and long, short and long, short and long. If we look at these angles, we see where each of these triangles meet, there is 1 copy of each of the 2 non-right angles. Now, we know in a triangle all 3 angles add to 180 degrees, and since our original triangle was right-angled, one of the angles is 90, which means the other 2 have to add to 90. So if we go back to this new square, if I look where these 2 triangles meet, this angle and this angle add up to 90 degrees. We've got a straight line. So the angle that's left over is going to be 180 minus that 90, which is 90. And what that means is we've actually created a square. So inside here, all of these angles are exactly 90 degrees. All of the sides are equal to the hypotenuse of our original triangle, which means that the area of this region in the center is c squared. Now, what we're going to do is we're going to keep that square, the big square, the same size, but I'm going to move my 4 original triangles. Now, an important thing for us to understand is no matter where I move these 4 triangles, they're going to cover up the same amount of the original square, which means the part that they don't cover is going to be equal in area to the c squared, even though it might not look like a square. So let's move those triangles around. So the part of the big square that isn't covered should be equal to the original c squared. But if we look at things, now the way that we've rearranged these guys, I've rearranged them into 2 rectangles, which means that this part here is going to be a rectangle with side A and A, which really just means that it's a square with area A squared. And this part down here is going to be a rectangle with sides B and B, in other words, A square with area B squared. And so we've shown that that original area c squared is equal to these 2 chunks, which is a squared and b squared. We've proved the Pythagorean theorem. I hope you enjoyed this episode of Math Shorts. If you check the video description, there's a link to the interactive sketch that I used in the video proof that you can play around with. Check in next month where we'll be looking at a number puzzle. Until next time, keep playing with your mathematics.